Okay, so in the previous video we explained how the double reciprocal plot is actually a straight line, but now the question remains, how does the competitive and the non-competitive inhibition affects the curve? So to understand that, we have to first find out these intercepts. This is the y-intercept and this is the x-intercept. The y-intercept is actually equals to the constant, and you can see the constant is 1 by Vmax. So this is 1 by Vmax. But what is the x-intercept? To find out the x-intercept, we have to just put y equals 0 in this equation. You can see here I have done that. Y or 1 by velocity is equals to 0, and you find out the value of x, that is 1 by s, 1 by substrate concentration, and it turns out to be 1 by km. You can see there is a minus, but the plot is actually, the x plot is actually negative plot, so this minus will not mean anything. Now we know the two intercepts of this curve. The y-intercept is 1 by Vmax, and the x-intercept is 1 by km. Now, what do we mean by competitive inhibition? In competitive inhibition, the maximum velocity remains constant and the km increases. So the 1 by Vmax should be constant because Vmax is constant, and km, as km increases, 1 by km should decrease. So this is for competitive inhibition. Now you plot this. As I said, the 1 by Vmax should be constant, so this point must be constant. The y-intercept is constant, but the x-intercept has decreased, so something like there. So the plot should be something like this. Okay, and then what about the non-competitive inhibition? In a non-competitive inhibition, the maximum velocity decreases, so 1 by Vmax should increase, and the km remains constant, so 1 by km remains constant. So this remains constant, and 1 by Vmax actually increase, something like there. Now plot. So this is how the inhibition affects the curve. That's